Assalamualaikum warahmatullahi wabarakatuh and good day. So from previous video, you have learned introduction of the function of random variables. So based on previous video, we have three methods to be learned. So in this video, you will learn first method, which is the method of distribution function. So this method is typically used when the y's have continuous distribution. So what is y? Y is a random variable. So in this case, it's s. So that means it's a function of random variables. So if you remember in previous video, you have y1, y2 until yn. Alright, so a function of that is mean. Okay, so this method is typically used when the y's have continuous distribution. So this one is similar. You know that you have continuous distribution and you have discrete distribution. Alright, so continuous, there is a way how to find the distribution function. Suppose you know how to find it from previous chapter. So in order to find the distribution function, okay, the probability distribution of the function, okay, first you must find the distribution function for u, where's your fu equal with probability u less than equal with u small. Okay, so by using the method that we discussed in chapter 3, we can do that. Okay, so first you must find the region in y1, y2, y3 until yn space for which u less than equal with small u. And then you find the probability u less than u by integrating the density function. So this is the density function of n variables, okay, a function of random variables over the region. And then the density function for u can be obtained by differentiate the distribution function of the fu. So basically this is the step. The first one that you must know here, you must remember, this method usually can be used for continuous distribution. Okay, for sure you know either the random variables is continuous or discrete, isn't it? Okay, and then this is the step how to do it. So now we look example. So before example, there is the info here. If y has probability density function fy, alright, so this is the density function. And if u is some function of y, then we can find this one directly by integrate the density function over the region u less than u small. Alright, so the probability density function for u is found by differentiate the fu. Okay, now look example 6.1, page 298. A process for refining sugar yields up to 1 ton of pure sugar per day. Okay, but the actual amount produced y is a random variable because of machine breakdowns and other slowdown. So you can see here the process is about the study is about process of refining sugar yield up to 1 ton of pure sugar per day. Okay, however, the actual amount produced is y. Okay, due to what? Due to machine breakdown or other slowdown. Okay, so suppose that y has a density function given by this stepwise function. So you can see this is the density function of y. You have 2y. Y is between 0 and 1. Okay, so the company is paid at the rate of $300 per ton for the refined sugar, but it also has a fixed overhead cost of $100 per day. Okay, thus the daily profit in $100 is equal with u equal with 3y minus 1. So if you look here, this is the function of a random variable. We have y is a random variable, but now we have function of random variables. That means y inside of a function. So in this case, we have a daily profit function which is equal with 3y minus 1. So the question asks you, find the probability density function for u. So u is what? U is a function which is inside have a random variable. Alright, so this is the solution, how to find the distribution function. Okay, first if you remember in the previous slide, the first step, okay, you will find this one. Okay, so you have fu equal with probability u less than u, and then you know that from the question u is equal with 3y minus 1, so you substitute here. Okay, so you have this. All right, then because we are talking about random variables, so you have y, you let y to the left side and then the others to the right side. All right, so then you get y less than u plus 1 divided by 3. Okay, all right, now you must understand the region. Okay, so if you look this equation, let's say I put u equal to -1. Okay, so it will give you, this function will be less than 0, isn't it? All right, because okay, -1 plus 1, 0 divided by 3, you get 0. Okay, so that is less than 0. Okay, and let's say if you have so you will get this equation. Okay, that's mean if u less than -1, you substitute inside here, you will get 0. So the distribution function will have this one. Okay, the first one. And then let's say if you put u equal with or greater than 2, okay, let's say we put 2 here. 2 plus 1 is 3. 3 over 3, you get 1. Okay, let's say you put 3 here. 3 plus 1, 4. 4 divided by 3, you still get 1. Greater than 1. Okay, so that's mean any u which is greater than 2, the distribution function will have equal with 1. Okay, however, if you look here, you have u -1 less than -1, and then you have u greater than 2. So in between two, you have u greater than -1 equal or less than 2. Okay, for this one, how to find the distribution function? We can use integration of the density function fy. Okay, so in case we have this one, all right, so you can see that between this one, actually you will have from -infinity to u plus 1 divided by 3 fy dy. Okay, but since here we have -1 and 2, we can consider from 0 until u plus 1 divided by 3, and then fy you substitute to y dy. So you integrate this one. Okay, before that, you integrate this one. Okay, you integrate this one, you get 2y square over 2, 0 u plus 1 over 3. Alright, so this one you cancel. Finally, you substitute the value inside here. You get this equation. Okay, so notice that y range from 0 to 1. So u range from -1 to 2. So you can see here, this is your u. Okay, but here is y. So it's range between 0 until u plus 1 over 3. Okay, to 1 lah. Okay, if you look at the here, your y is 0 until 1. Okay, so thus the distribution function of random variable u is given like this. So you can see that, okay, this is your fu. The first one we're talking when u less than -1, it's give you 0. When u greater than 2, it's give you 1. But between u -1 and 2, this one you get from here, it will be u plus 1 over 3 square. Alright, so this is the distribution function of a random variable u. U is what? U is 3y minus 1. And then in order to find the density function for u, you differentiate. So you differentiate the first one is 0 for sure. And then here you differentiate this one, you get what? Okay, differentiate with respect to u lah, because your variable here is u. Okay, so this one you bring out 2 down 2. So actually this one, if you remember, this is differentiation you have learned before, but I just show you. You can bring out 1/9 here, and then you have u plus 1 square. So when you differentiate this one, you get what? 2u plus 1. 2 minus 1 is 1/9. So you get this one. So what's the limit? From -1 to 2. And then 1, when you differentiate, you get 0. So this is the final answer for the density function for u. Okay, so important here, you must remember, this method usually will be used when you have continuous random variable. Okay, and then first you need to find the distribution function for this one. So in order to find this one, you must know the limit, the region. So this is how you check the region. That means from here you can check if u is less than -1, how is it? If u greater than certain amount, how is it? And then in between, you can find using this one. Okay, you integrate. Okay, and then you will get the distribution function like this. And then in order for you to find the density function for the function u, you need to differentiate. All right. Okay, so I think that's all for this video. I will try give you another example for this method. You could try exercise given. Okay. All right. Thank you, class.